Okay, all right. So sequence detector. So they're gonna be a series of bits, which is going into the sequential circuit, and it's gonna look for a sequence 1001. And when it detects that sequence, the output is gonna go high. So we have an input right here. So say this is your X. You're gonna have clock here, and then we have the output here. Okay. So notice we have the input here, 1110. The output is going to be 0 here. When this bit is received, the output would still be 0. It will be 0, 0, 0 until it gets here. This is when it detects the sequence 1001. The output goes 1 here. Okay. Here output will be 0, 0, 0, 0, 0, 0, 0. What would be the output over here? Again, this detects a sequence 1001. The output goes 1. Now there is two things that we could do. We can actually do this by overlapping or without overlapping. Okay, so you see there's another 1001. We call this overlap. Okay, this example we're gonna do it with overlapping. Okay, you can, if you wish, you can do it without overlap as well. And then so this is 0, this is 0, this goes 1, and then 0, 0, and then so on. Okay, all right. So a sequential circuit is able to remember the inputs from the previous clock cycles. For every clock cycle, one input comes in order to determine whether the specific sequence appeared. Our second step is to come up with the state diagram. How many states we're going to have here? 4 states. Remember, our goal is to have like minimum number of states. So we can do this by 4 states. S0 would be the one which would be the sort of like reset, and this is when we start detecting. Okay, nothing is arrived. This is sort of like a reset. This is when it starts detecting. So it's actually awaiting what 1001. Okay. Then the next state. So this will be 0, 1. It receives 1, and now it's awaiting 0, 0, 1. Okay. Third state S2, which is 1, 0. Here it receives 1, 0. Now it's awaiting 0, 1. And the third state, it receives 1, 0, 0, and it's awaiting 1. Okay, so this is a good approach to start with. Again, there are multiple ways of doing it, but I think this is probably the easiest one to do it. Remember, you got your input and output. Input is your X, Y is your output. Now that we have the state diagram, the transition sequence, we're going to work on our state diagram. Okay, so this is going to be our S0. This is S1, S2, this is your S3. So 0, 0, 0, 1, 1, 0, 1, 1. Here it starts detecting. Here it has received 1. Here it has received 1, 0. Here it has received 1, 0, 0. Okay. So say the initial state is S0. 0 comes in. What is going to be the next state? Yes, it's going to stay there, right? So input is 0, output is going to be 0. Present state is S0. This is where it starts detecting. 1 comes in. What is going to be the next state? S1, correct? Okay. Input is 1, output is 0. Now the present state is S1. 1 has been detected. 0 comes in. What would be the next state? S2. So input is 0, output is 0. If 1 is detected, what happens then? It stays there, correct? Because we're looking for sequence 1, 0, 0, 1. So 1 comes in, it stays here, output is 0. Now the present state is S2. 1, 0 has been detected. Now it's looking for 0. So if 0 comes in, what would be the next state? S2, S3. Okay, so 0 comes in, output is 0. If 1 comes in, what happens? 1, 0, that's the present state. 1 comes in, what would be the next state? Yes?
S0.
S0? Okay. Anybody else who has a different? Yes? We can go to S1, right? Because that's where 1 is, correct? So we can actually go here. Okay, remember we are doing overlapping, correct? Yeah. Okay, now present state is S3. 1, 0, 0 has been received. It's looking for 1. 1 comes in, where does it go? What would be the next state? S0? Okay, alright. Anybody else? Yes? S1. Why? Because we're doing overlap. Okay? Alright? So this goes here. So here, input is 1. The output is going to be 1. Okay? If 1, 0, 0, and then the output input was 0, what should be the output then? Then it goes to S0, correct? There you go. Output is 0. So our state diagram is ready. Okay. Okay. Let's move on to the next step, which is coming up with the state table. This is also the step where we choose our JK, our flip-flop, and we will be using JK flip-flop here. And because we have 4 states, so we need 2 flip-flops, correct? Okay, again remember this is your S0, so 0, 0, 0, 0, this is your S0. S1, S2, and then S3. Okay, these are your 4 states. Again, we know that in the state table, we put our present states and the inputs right next to each other. So, present state is 0, 0. Input is 0. What is going to be the next state? It's going to stay there, 0, 0, right? Present state is again 0, 0. 1 comes in. It's going to go to 1. When 1 came in, it went from S0 to S1, which is 0, 1. So we have 0, 1 here. Alright? Now we need to fill the rest. Now the present state is 0, 1, which means 1 has been detected. 0 comes in. What would be the next state? 0 input. It goes from S1 to S2, which is 1, 0. Okay? Which is 1, 0. The output is 0, 0, 0 here. Okay. If the present state is 0, 1, which means 1 has been detected, and then next the input comes in as 1, what would be the next state? 0, 1, right? We'll stay there. Okay. So let's finish this real quick. 1, 0, this goes to 1, 1. 1, 0, 1 comes in. Where does it go? It goes to 0, 1. Correct? And then 1, 1, that means 1, 0, 0 has been detected. 0 comes in. Where does it go? So 1, 1, 0 comes in, it goes to, oh sorry, 1 comes in, it goes to 0, 1, correct? Which is right here. And then 1, 1, 0, 1, 1, 0 comes in, it goes to 0, 0. So this is 0, 0. Okay, does the state table looks okay? The next states, everybody agrees? Okay, alright, let's move on to the JK. Now these 2 columns we need to fill. Again, we have the excitation table here. This will be given. We're going to start off with J1, K1. So you're looking at Q1 and Q1 asterisk. 0, 0. 0, 0 gets you 0, don't care. Sorry, 0, don't care. Don't care. Okay, then we have 0, and then 0. So 0, 0 will give you 0 don't care again. Then we have 0 and 1. 0, 1 gets you 1 don't care. Then you have 0 and then 0. So you can have again 0 don't care. 1 and 1. 1 and 1 gets you don't care 0. 1 and 0. 1, 0 gets you don't care 1. 1 and 0. Again don't care 1. And then 1 and 0. That gets you don't care 1 again. Okay. Now we're gonna move on to J naught and K naught. So we look at this column and then this column right here. So initially we got 0 and 0. 0, 0 gets you 0 don't care. Okay. 0 and 1. 0, 1 gets you 1 don't care. 1 and 0. 1, 0 gets you don't care 1. 1 and 1 gets you don't care 0. 0 and 1 gets you 1 don't care. 0 and 1 gets you 1 don't care. 1 and 0 gets you don't care 1. And then last one, which is 1, 1, don't care 0. Output will be 0, 0, 0. What would be the output for the rest of the two? Yes, guys. This will be 0, and this will be 1. Good, awesome. Okay, now we're gonna do K mapping now. Get the expressions. Let's look at the minterms for J1. So I got this is 1, and then 4, 5, 6, 7 are don't care. 4, 5, 6, 7 are don't cares. Okay, so I think everybody can agree we can go with this one, right? Okay, so J1 is going to be, what's the expression here? Q naught dot X bar, correct? Let's do for K1. So looking at this one, this column. Don't care, first 4 are don't care. And then 5, 6, 7 are 1. Okay, how would you do this one, guys? It's a little tricky. Again, our goal is to go for a maximum size. So yeah, someone else. Come on, guys. Yes. Yes.
Reduce 4.
Correct. So 1, 3, 5, 7 and 3, 2, 6, 7.
Yep.
Okay. All right. Good. This one, and then this one. Okay. So we'll go with this expression first. This is going to be what? X. And the expression for this one is going to be Q naught, right? Here's your K1. Okay, now let's do it for the J naught. So we look at this one, this column. This is 1. This is don't care. This is don't care. 4 is 1. 5 is 1. Don't care, don't care. How about this one? Yes, guys. I can go with this card in the middle. What else? On the bottom? Okay. Okay, so this one was simple. This is going to be Q1, right? Q1 plus. Here the common is X, right? So K2. Sorry, this should be J naught and this should be K naught. Okay, so make sure you make this change, guys. This is J naught and this is K naught. Okay, so K naught here. So this is don't care, this is don't care. We got 1 here. 4 is don't care. 5 is going here. Okay, how about this one? Wrap around, make a chord. This one right here, and then this one right here. So K naught, what would be the expression here? X bar, correct? X bar. What about the Y? What would be the expression for Y? There's only one min term, correct? If you look at the Y output, right here, there's only one min term, which is this one, right? So we'll just go with this expression right here, which is what? Q1 dot Q naught dot X, correct? Okay, alright, everybody follow me here? Okay, cool. Let's go to our next step, which is the last step, coming up with the sequential circuit. Okay, I got my J1 and K1 here, and I got my J0 and K0 here. Okay, so let's work on J1 first. J1 is Q0 dot X bar. So I can okay, this goes here. One of the inputs is this X. So this X bar. And then Q0. Q0, which is basically this. So you wire this right here. I'll just write the name of the variable. Let's work on K1, which is X plus Q0. Okay. Okay. Q0 here. Obviously, this is going to be the clock. Positive edge, right? Okay, let's now work on J0 and K0. So J0 is what? Q1 plus X. One of the inputs is Q1 and X. Okay. Cool. K0 is X bar, which is right here. So I can just okay. All right. Anything else that I'm missing here? Yes, folks. Anything else that I'm missing here? Our output, correct? So what was the equation for the output? Y equals to Q1 dot Q0 dot X. So maybe I can just okay, so Q1, which is right here. We need X also, so I'll just so this is your X, so Q1, and then Q0. So let's get Q0 from here. This is your Q0. Okay, so, and this is going to be your Y. Remember, this is an AND gate. Okay. Output. Okay, so this is your sequencer, right? And it was detecting 1, 0, 0, 1. So you can expect something like this in an exam 3. Okay, so this could be one example, one problem. We're gonna move on to any questions, guys? Shall we move on to our next example? Okay, our next example is actually analyzing a sequential circuit. There comes a time, as an engineer or as an engineering designer, you have to sometimes reverse the process and unlock the logic behind it, right? So this is what we are going to do. So we're gonna reverse the process. We have a sequential circuit. Using that circuit, we're gonna come up with the expression. And then with the expression, we're gonna get the state table, and then using the state table, we're gonna get the state diagram, and then we'll try to define the function. Okay, what is it doing? Okay, so it's a D flip-flop, correct? Notice I actually use logic M. So the clock appears over here. Okay, so we got two clocks for two flip-flops. This is your output Q1. This is flip-flop 1. This is flip-flop naught. So this is your Q naught. Actually, let me write it down here. Q naught, Q1. These are the present states. And this is your next state, right? This one and also this one. If this is X, this has to be what? X bar. Okay, and what is this input going into this? This is what, guys? X, right? Okay, alright. This X is also connected to this mux. This is interesting, huh? You have Q naught here, and you have Q1 here. Notice this is Q1 here, and this is Q naught here. And you got X here, and output. Okay, what is Q1? What is the expression for the next state for the flip-flop 1? Yes, guys. Where's flip-flop 1? It's right here. Where's the next state? It's right here. And the next state is what? X bar, correct? So X bar. What about the next state for flip-flop 0? X, okay. Okay, what about Y? What is the expression for Y here? Anyone? This was the first thing we did when we did multiplexer. Anybody recall that? Okay, so we'll just do a truth table, and then using a truth table, we'll come up with an expression. So if X is 0, what is going to be the output? If X is 0, what is going to be the output Y in terms of the expression, like a variable? Yes? Q0. Remember this, it's going to be Q1 because this is your data line 0, but it's labeled as Q1 because you have Q1 connected to it. So here was a small trick here, okay? This is your data line 0, this is your data line 1, and so on, 2, 3, 4. But at data line 0, you have Q1 connected, okay? So when X is 0, your output will be Q1, okay? And and we really don't care about Q naught here because it's not going to be our output. So if X is 0, Q1 is 0, Y is going to be what? Yes, folks? 0. If X is 0, Q is 1, output is going to be what? 1. Correct. Okay, similarly, when X is 1, which means the output, if X is 1, then your Y is going to be Q naught. Okay? Really don't care what Q1 is. If X is 1, Q naught is 0, so Y is going to be what? 0. Right? And similarly, if Q naught is 1, X is 1, Y is going to be 1. Okay, so we have two main terms here. This one and this one. Okay, so what is going to be the expression here, folks? What is going to be the expression for this one? Yes. X bar Q1, right? X bar Q1 plus, what about this one right here? This will be x q naught. X q naught. Q naught. Why are we not including these don't cares? Because this is a mux. Only one output can go through it. Only one input will go to the output, not two. Okay, so we have three expressions. This is for the y. Okay, we're gonna move on to our next sheet. Okay. We're gonna go on to our constructing our K map. Again, different ways you can do this. You can jump from logic expression to state table also, or you can go from logic expression to K map. For example, if you look at your Q1, the next term for the flip-flop 1 is actually X bar, right? So if you look at state table, you got your present states and input right next to each other, and Q1 is actually equals to what? X bar, correct? So this is X bar. When X is 0, Q1 asterisk is going to be 1. This is 1, this is 0, so just a complement. 1, 0, 1, and 0. Okay? So, if you do a key map for Q1 asterisk, then you look for minterm. 0 is 1, 2 is 1, 4 is 1, and then 6 is 1. Okay? So we make this card right here. And then what's the common here? It's X bar, right? And that is what we had over here also. Okay? So this will, let's say this is going to be Q naught, the next term for the flip-flop 0. Okay? And you have this expression X. Okay? So notice it's going to be a vertical pair, because you really can't find a common here. And it is X, so where should be the minterms should be? Yes, guys. If I have all these ones, because this is what X is, right? X and X. If I have all those two columns as ones, what is the expression I'm gonna get? What's the common here? X, right? And definitely we cannot find any common vertically, so it's going to be X. So I did it two ways, going from here to state table, and then from going for here, just putting the minterms, looking at these values right here. So you can do it whichever way you want to. We have another one which is for Y. Let me write the value here. Y to do X bar Q1 plus X Q naught. Okay. So where the minterms are going to be. Say you want to make this expression X Q naught. Where the minterms are going to be. Look for X Q naught in your cells. Where would be X Q naught? You got your Q naught and X. Q naught X, right? So this will be 1 and 1, right? So if you make this pair, it will actually make this term right here. Correct? How about this? X bar Q1. Where's X bar common? Yes, Hunter.
6 and 4.
6 and 4. So X bar is going to be here and here. 6 and 4. And then I'm assuming that you said 6 and 4 because we got Q1 here, correct?
Yes.
Okay. So we got 1 here and then 1 here. So if we make a pair here, this pair is going to give us this term right here, X bar Q1. Okay. Let's finish our state tables real quick. Q naught was X, simple X, right? So if X is 0, Q naught is going to be 0. This is 1, this is 1. Just follow along. 0, 1, 0, 1, 0, 1. What about Y? This is your Y. How would you do this? Like, what is the first thing that comes to your mind? One simple way is to try these combinations, like putting Q1 0, Q0 0, and X 0 0 in this equation and see what comes out, right? Correct? What could be other option right here? You always look for like something which is the faster. Yes.
Just like putting the ones in the corresponding like 3, 4, 6, and 7.
3, 4, 6, and 7.
With the present state input.
3, 4, 6, and 7. So this will be 3, 4, 6, and 7. So you said these will be high. That is right. How did you come up with that?
Because it was already in the K-map.
It was already in the K-map. That is right. So again, depending upon like which way you do, you can get this state table complete. One way, say if you were going from state diagram to state table, you already have the not state diagram, but actually would it be, yeah, from here when you had these logic expressions, okay, from Y, one of the option could be, well, this is making what kind of gate? X Q naught is making an AND gate. That means whenever X and Q naught are high, output is going to be high because this is the OR gate, right? Any of the input high, output is going to be high, correct? So if you look at your X Q naught, whenever these are high, the output is going to be high, okay? And she just also mentioned that 3, 4, 6, and 7. So if you look at 3 and 7 are high, okay? So just one way of doing it. So now because we had the K-map, so we will just fill it in real quick. This is going to be 0, this is going to be 1, and this is going to be 0. So this is our Y. Now we're going to do our state diagram. This is our S0, S1, S2, and S3. Remember, this is your S0 here. This is your S1, S2, and this is your S3. Okay. So 0, 0, 0, 1, 1, 0, and 1, 1. So if present state is 0, 0, X is 0, what is the next state? Next state is 1, 0, so it goes here. Okay. Input is 0, output is 0. Present state is 0, 0, X is 1, goes to 0, 1. Input is 0, output is 0. Correct? Okay, now we are here. Present state is 0, 1, this right here. X is 0, it goes to 1, 0. Goes to 1, 0. X is 0. Output is going to be what? 0. 0, 1. Input is 1, goes to 0, 1. That means it stays there. It's 1. Output is going to be what here, guys? 1. Good. Now present state is 1, 0, which is right here. Input is 0. Next state is 1, 0. So it stays here. What is going to be the output? 1. Okay. Cool. Now this one right here. Input is 1, goes to 0, 1. Input. Say it again.
When your S0 has an error, it has 2 arrows coming at us from the 0. For 0 input.
S0 if it's 0, so it goes to 1, 0. 1, 0, okay. 0, 0 if it's 1, it goes to 0. So this is going to be 1. Okay? So this one right here is 0, 0. Input is 1, it goes to 0, 1. So it goes to 0, 0 to 0, 1. So the input is 1. Okay? Thank you. Where were we? This one. 1, 0. Input is 1. 1, 0. Input is 1. And then you go to 0, 1. So input is 1. What is going to be the output is 0. Then we are 1 1 here. This is your present state now. Input is 0, we go to 1 0. Output is going to be what? 1. And then if you are at 1 1, input is 1, you go to 0 1. You go all the way to here. Okay? Input is 1, output is going to be 1. Okay, now having this state diagram and describing the function is a little tedious task, but if you actually look it up, if you actually create this in a Logisim, you should be able to verify what kind of a state machine it is. This is actually for detecting consecutive ones and twos. Consecutive ones and zeros in the binary sequence. Okay. These were the two examples I had. We'll finish a little early today. I just want to give you more time to work on your projects. So after the class, feel free to comment. I'll be available until 3. Okay.